People very often ask me both how and why I started my podcasting journey. Well, as an engineer, I'm frankly very passionate about math. I wanted to find somewhere to share stories of great mathematicians from Archimedes to Alan Turing and everyone in between. And for that reason, I want to tell you a little bit about my preferred hosting platform, which is Zencastr. Now, before I continue, this is usually the conversation I have with anybody who is wanting to start their own podcast. I know there are so many people out there with passions that they want to share with the world or unique knowledge that they're just looking for a platform to start with. And Zencastr is a wonderful all-in-one platform. What I mean by that is you can do your recording and your editing and use AI to create a transcript and distribute to all platforms, including Apple Podcasts or Spotify or anywhere else where podcasts are played. For anybody like me who might worry at first about what you might sound like on an audio recording, Zencastr's post-production process makes you sound really, really smooth. It automatically removes any of the ums or ahs in your recording. It removes any of the awkward pauses in conversations, and it also helps you to set the right podcast loudness and levels while reducing any background noise, all with the click of a button. It couldn't be easier. Go to zencastr.com/pricing and use my code BREAKINGMATH, and you'll get 30% off your first month in any Zencastr paid plan. I want you to have the same easy experience I do for all my podcasting and content needs. It's time to share your story. Fairly often, I get asked questions about how I got started podcasting with the Breaking Math podcast, and I'll often be asked this question by those who are thinking of starting their own podcast. That is, people who are looking to tell a story or share their unique wisdom with a larger audience or their passions, or maybe just advertise their business or services. I usually like to start this conversation by either showing off or telling about our preferred podcasting platform, Zencastr. Zencastr is essentially an all-in-one podcast hosting platform. On this platform, you can do everything from recording your episodes to editing your audio and video files to distributing your podcast to all podcasting platforms, including Apple Podcasts, Spotify, iHeartRadio, and wherever else podcasts are played. Now, there's more. When I first began podcasting, I used to get very nervous about how I would sound. I would sometimes stutter or have awkward pauses or other audio blemishes in my recordings. Now, Zencastr has a new suite of AI tools in their post-production process that make you sound really smooth. They automatically take out any of the ums or ahs in your recording. Also, they automatically take out any of the awkward pauses in your discussions. The tools will also help you set the right loudness and balance all the levels while reducing any background noise, all with the click of a button. Doesn't sound too bad, does it? You really should check it out. Really, the world needs to hear what you have to say. In fact, I'm going to give you a code below to help give you a large discount. It's all one word, Breaking Math. Go to zencastr.com/pricing and use my code BREAKINGMATH, and you'll get 30% off of your first month in any Zencastr paid plan. I want you to have the same easy experience I do for all my podcasting content needs. It's time to share your...
What is intelligence? That is the question that a lot of us have been asking ourselves as AI is showing up in more and more places. Some of us are using it now at our jobs. Some of us may be fearing that someday AI may make our jobs unavailable. Some of us only know AI on our phones and on our other devices. A lot of us have a lot of questions about what AI is and how it works. We wonder specifically, what exactly does AI know? How does AI know what it knows, and what does AI not know? These questions are critically important as they relate directly to our safety. They relate to the reliability of the products that we're using that have AI as part of them. They relate directly to our ability to do what we do as humans in our hobbies and in other pursuits. These are the kind of questions that we're going to be talking about right here on this show. Real quick. For the last several months, I've picked up a book here. It's called A Brief History of Intelligence by Max S. Bennett. Essentially, what this book does is it talks about brains and brain-like organelles all throughout nature. There are chapters that talk about brains in insects or in fish or in reptiles or in mammals and humans. And it talks about how they know what they know, and essentially what hardware, between their ears is required for that. It is fabulous. Quick example from the book, my favorite example is it talks about reptiles, and it says that reptiles, unlike humans, are not able to visualize their own body inside. So if an alligator is walking and it steps over an obstacle, it is unable to move its back legs to account for that obstacle. It just runs right into it. Its back legs, I don't want to say are on autopilot, but it certainly doesn't have the ability to visualize. That's amazing. That fascinates me. So I suggest to any of our viewers or listeners, check out this book. You can go along. We also have a discussion happening on Slack at Breaking Math Podcast or Breaking Math Pod, as well as Discord or even our emails here. So, hey. Now, I have a very special guest today. My guest today is a creator who has worked with Khan Academy. He has worked with Pixar, with Disney. He has worked with Google. He runs a YouTube channel all about electrical engineering, computer science, and machine learning. And for the last 5 or so years, he's been making a series of documentary-style videos on machine learning. His name is Brit Cruise, and I'd like to introduce him. Brit Cruise, welcome to the show. How are you, sir?
Hi, Gabe. Thrilled to be here.
I am thrilled to have you here. So I'll just tell our audience again, since you've been in this field for at least the last 5 years, but really you've been doing your channel on computer science for the last 11 years, is that right? You have a lot to say on this topic. Can you real quick tell our audience a little bit about the history of your YouTube channel as well as your work at Khan Academy?
Sure. Actually, it's funny because it connects to memories. So when I think back, there's one strong memory, which is I was, I think maybe 20 or something, and left while I was in university or right after I finished. I went and did the classic working on the farm in the summer. Just went way up north Quebec. And again, just thinking back now as a parent so busy with kids, having that sort of like weeks or months of total clarity, just literally digging holes, doing farm work, and then at night having no internet. Towards the end of that trip, I remember being like, all right, I've got to go back to school in the working world. I'm 20, what am I going to do? And in one notebook, I was like, well, what are you good at? List some things. The two things were I knew I was good, or good is what you're excited about video making in all forms. Also happen to be good at explaining things. And again, that's an interesting skill. I don't know if it's learned or innate. And so I just wrote like, I'll just do, and I also like some old TV shows like Connections, and I'm like, I bet if I did my own show, that would be good. And I wrote literally like I would do a show on cryptography, and then I would do information theory, computer science, physics, and one day I'd get to AI, and it's at the end of the book. And I know because it's one of those, I kept 1 or 2 books in my life and threw it in a box in the attic, and that one's in there, and actually climbed up and looked like over a decade later. I'm like, wow, that little insight on that farm was a thread that continues to this day.
Wow, very cool. Very cool. And then, so I know there's a lot more to go from that, you worked as a computer science teacher, but I saw that you have a very unique approach. And I'm sorry, I don't mean to skip around. I'll go back to the farm story in a second. But
no, skip around.
Oh yeah, sure. Why not? You have a unique approach to computer science. I've heard traditionally a lot of folks don't like a degree program that focuses on here's all of your tools that you may or may not use. And I know that on your channel specifically, you don't start with the tools. You start with looking at the problem. Can you tell us a little bit about that?
Yeah. And so I can put it in one line, which is you got to teach forwards, not backwards. And just as you're saying, it actually got like chills on like literally the torture of going through, let's call it a computer science program circa whatever, not this year. I don't know what it is this year, but since all of history, it was a lot of pain and struggle that didn't need to be there. I think it's just kind of imposed on purpose to filter people out. That's an argument about universities, but in the context of computer science, teaching backwards is like trying to keep up with a bunch of modern things, a lot which won't even matter in the future, and then sometimes in a course being like, oh, and 200 years ago, so-and-so said that. And like, you're like, and I remember in school, there was like 1 or 2 moments where I'm like, what? There was something before we even had electricity that matters in computer science. I want to know more. And so the takeaway there is when I was thinking about how I would teach is kind of simple. I would just teach forwards. Teaching forwards means you have to unlearn what you know and go back to a blank slate. Oh man, that's important. And if you can go to a blank slate, which is any teacher can just naturally a good teacher can just jump to blank slate and rebuild an explanation in that moment. That is what you have to do. And so that's how I approached it.
Wow. So here's the amazing thing as you're talking about this. This relates directly to the philosophy of machine learning itself. And I'm sure you're probably aware of this as well. Mm-hmm. Where with machine learning...
Big mess.
Yeah. Like, you don't tell machine learning how to solve the problem. You literally just tell it the parameters and say, teach yourself how to solve the problem. And then through trial and error and playing things, it discovers itself. Machine learning can teach itself how to play chess, or how to play the game Go, or any other game, or any other, or a wide swath of other problems. And so, the optimal learning for humans is similar to AI, where we figure out the tools and just have freedom to explore. I love that. You said earlier that you had a natural...
Can I interject?
Sorry, go ahead.
Yeah, so you just gave me a thought, which is on the philosophy of machine learning. You could look at it on the one hand as a very simple thing as can humans take their hands off the controls? And the divide is from the beginning. You have humans who want to have their hands on the controls because we're smart, and we are going to have good ideas, and we feel good when we have good ideas. And that's what we call good old-fashioned AI, literally writing the code step by step for how to be smart, which is, again, the classic example. It hits a wall with images because it's too complex, so human algorithm won't work. The other camp, going back to the beginning, was we're going to model biology, and we mean it. We're not fake, like kind of modeling biology and then writing all this human code around the edge. And so that's the connectionist theory, which is we're going to build, and this is important because it's going to connect to future questions. We're going to build a mesh of connections, and we don't even care about those connections. They could be random, or we could have all of them, and we're going to learn what we need to do to perform based on some reward. And that thread has always been there, and people are usually on one or the other, very rarely both. And so just like a political divide, it's been fun to watch the history of this as the people who need to have the hands on the controls and don't, and that leads to the divide today. And so it's so simple, but I can't say how important that divide is.
Oh my God.
It's just the research today, you could put the papers in two different piles.
How about I do this? How about I ask an AI if, in the style of Jordan Peterson, it can summarize the divide in philosophy between chaos and order, and getting order for your life by using chaos appropriately, or something like that,
As long as it doesn't have a Canadian accent, I'll take it seriously.
Oh, for sure. Yeah, I love this. Okay, so many things I was going to say before. So you mentioned a penchant for education. I'm actually a former educator. It has been told to me that I'm very, very good at explaining things before. I had a miserable time in education. I think I had like anxiety and panic attacks, and it like crippled my classroom management. I had a rough go at it, but I salute teachers who are good at it. They are an inspiration. But still, I still have I've been told, at least, I have an ability to explain things with stories and analogies, which is also a part of machine learning and how knowledge is stored distributively. We'll get to that here in a bit. So it's interesting. I want to mention my late co-host, Sophia Baca. She would love this conversation. She would love talking to you, and I miss her very much. We've done an episode already how Sophia passed away this last year, and part of why I want this show to go on is in honor of her and the way she'd like to do things. She was very, very creative as well, but also my math tutor. So I was able to somehow code switch between creative ideas and analytical ideas. And how do you meet people who are good at doing both? Sophia was definitely one of those people, and left their imprint on this show for sure. Amazing individual. So yeah.
Happy to be part of that effort.
Yeah, thank you. I admire, if you don't mind, I'll say you and I are not too dissimilar. We both started off having a show that came out of our enjoyment of math, science, and creativity. In your case, your show is Art of the Problem on YouTube, and our show is the Breaking Math podcast. We are totally riding the coattails of Breaking Bad. Somebody once said, "What if you call your show Crystal Math?" And I said, "No, I don't think we're going to go that route." But So I love the idea of creative storytellers who are sharing science knowledge and analytical knowledge. So it's kind of a cool way of reflecting on the history of knowledge. Now, in this show, to give our audience a quick preview, we are going to talk about some of Brit's previous videos that follow the same format as this book, where they break down knowledge in nature, in brains in nature, and then they get to the history.
Happy accident.
Yeah. Very cool, very cool. Yeah. So I suppose I watched every one of your videos these last 3 weeks, and I tried to summarize them. And essentially, whenever I watch a good sermon or a good talk, they usually have like a big 5 takeaways or a big 3 takeaways. I had a big 3 takeaway from your videos, but then I made it a big 5 takeaways. 3 takeaways about layers of learning, and then 2 additional takeaways about what neural networks are and how they learn. Let me know how I do on the big takeaways, and let me know if you can elaborate on this. What I wrote is, from watching your videos, the 3 takeaways with learning are that in nature, you have examples of trial and error, which involves randomly trying something and then reinforcing it. That is used all throughout nature, including when toddlers learn or when bacteria is spreading or just about anywhere we look. There's another layer that's a little more complex, and that layer is what we know of as classical conditioning for those who have studied psychology. That's when, was it B.F. Skinner, I believe, who trained his dog to salivate whenever he rung a bell, because his dog began to associate that type of learning with a bell, from he would always feed his dog whenever he rang the bell, and eventually just the bell itself would cause salivating in his dog. So that's associating a sense and an experience. And then the third form of learning is the most impressive. I think it's abstract imagining, and according to this book, it's how humans and mammals have the ability to imagine scenarios where you can play out a scenario in your head. You can imagine what happens if I walk over that pothole and I fall, but you don't actually do it. It's a step beyond associative learning, and I've heard it called internal modeling and simulation. Would you say that's a pretty good summary on the layers of learning?
Yeah, that's really good. And so I'll just compress your summary now, because which is that in the 3 layers, the first one is genetic learning, and the reward is life or death.
Yes.
And the way it manifests is our genes spill out into pre-wired connections that stay fixed our whole life, and that's why insects. You were saying earlier, he is on that alligator, and it's a he.
Oh yeah.
Is on autopilot in that context, but more specifically, when I start the video, it's that insect brain, fixed connections. That second layer is then we spill out into connections. Our DNA spills out into the ability for connections to change in life, so changeable connections. That's the key. And then what's neat about the third layer, it has nothing to do with connections changing. It's thought patterns in our brain are kind of at a higher level of abstraction, making connections.
Right, nice. And right now, I'd say if we're talking about neural networks, I've been trying to find the list of activities that neural networks can't yet do quite right. This is where there's some ambiguity with our current technology and what neural nets can do. Can you name some activities that right now a neural network, whether it's Chat GPT or anything else, cannot do?
Sure, yeah. 2 quick points.
Sure.
Point 1 is be very careful when you hear someone say what neural networks can't do.
Yes.
99.94% they're wrong. And I'll give an example where I even found myself wrong, because there's a human instinct to draw a line way out and do the meta thing on the machines and be like, you'll never catch me up here.
Oh yeah.
And the one practical one I had is, and this is true, anytime it has a strongly learned pattern, something it's known very well, and in the human analogy, it would be some over-habituated behavior, like looking at your phone. It's very hard to do the opposite. This is also known as it connects to the no free lunch theorem. You learn something, there's a cost. And so I was using, even in some talks, my favorite was, you can't play tic-tac-toe backwards. And I tried all the models and they all were failing, and I was like, I get to be up on my high horse, my human horse, and make fun of it, and everyone laughs in the crowd. And I remember in one talk, like, what is this, 4 months ago? It feels like 10 years. I'm like, once it does this and other similar examples, then I'll be kind of scared. And guess what? Now it can easily do that when we went to the GPT-4 model. And so, A, be careful.
Okay.
B, where does it actually also, like, I'm still kind of sure it fails, is self-awareness. And so the practical thing there is runaway errors, not being aware of errors as it is making them, and it leads to this explosion of errors. By the way, I want to talk about hallucinations because people got that wrong. But even see, when I say that, it's not self-aware of itself and it's going to have runaway errors. I already know of research where they're trying to, again, just add another layer of a neural network, in this case a large language model, looking at itself, and you can get out of that error. So I'm trying to partake that it's not a list of what it can do and not do. It's a very blurry, everyone's walking in the dark with their hands out right now.
Oh, that's so philosophical, that's so existential, and that's the world that we're in right now, isn't it? I love it. Yeah. Oh man,
you got to stay that high.
Yeah, in fact, that's literally what we're talking about at work right now, is when Chat GPT hallucinates. I've got a guy at work that says, well, let's just create an app that does a quick fact check on it that splices out the factual information, which is a patch. But even humans continually make mistakes. Humans, the way our brains work, we always have our own runaway mistakes. So I think it'll be an ongoing process, and every patch is going to be between 0 and 100%, 90% effective. And with Gödel's incompleteness theorem, I think that there's always it's always an evolving game. So fascinating topic.
Just back to the divide of hands on the controls or not hands on the controls.
Yes.
What camp are those people in? Quiz to you.
Yeah, absolutely.
What's the patchers? Where would you put them in?
Yeah. So okay. So for those who are following, real quick, you said there's the 3 modes of learning, or 3 layers. There's trial and error, or randomly trying something. There is classical conditioning, and then there is imagination and simulation. I want to talk about points 4 and 5 real quick. These are points about the philosophy of machine learning in a neural network. The first thing that we're going to talk about later in this episode is, in a neural network, a concept, or concepts plural, like dogs and cats, they're stored distributively like a constellation of stars, but like throughout layers of a neural net. And multiple concepts, like a dog and a cat, are going to share a bunch of the same things. Like, they have a lot of similar architecture and similar attributes, and they've both got 2 eyes, and a mouth, but they're different as well. So in a neural network, like our own brain or machine learning, it's stored distributively, and they're also connected. Is there a better way to word that you can think of, Brit?
You're doing a great job, by the way.
Thank you.
And so I like to go back to feelings. Let's teach forwards.
Yeah.
So we have feelings, and so we can use any example, but even if I use one of a tree, when we both think about a tree, we simulate a tree, and that means a repeatable, unique set of neurons activated in our brain. And there's technology today that can actually know what you're thinking just by looking at your neurons. But why that's important is, so a unique group of neurons, what is that from our perspective? That's a feeling. Yeah. When we're feeling different things, and this is the thing, there's 2 layers to feeling. I think about concepts as a mental feeling. So like the feeling of an appleness versus a sponge. Yeah. Those are unique neuron sets, and we just feel them as different feelings. And so neural networks are storing the things we perceive as just unique. I like how you said constellation in the stars. That's a good one.
Yeah, thank you. I use that on your YouTube. In fact, quick story for our audience. I probably put 20 plus comments on Brit's YouTube asking him a million questions about AI and consciousness, and you thankfully responded, which brings us to our conversation today. So yeah, go to the YouTube channel, Art of the Problem, and Brit is very responsive, and so are the other folks. So yay, thank you so much. I appreciate that. Now, that concept of distributed concepts, in a constellation, that is a recurrent theme as we talk about what machine learning knows, because there's a push to understand all those connections. It's very random at first, but as we understand it, we can say, okay, so at this layer, we're putting together textures. At this layer, we're assembling the textures. That helps us to know what machine learning knows, and it's helpful. Even that itself is knowledge, which is helpful for other things. There's an AI that we'll talk about. There's examples of AI. One of my favorite sections here is after our background stuff. We have examples of AI. There's an AI that identifies bread in a Japanese bakery that has now been repurposed. I shouldn't say repurposed. It's been a similar architecture has been used to identify cancer in or precancerous images on I believe it's MRIs. I believe I'll have to check that. But it's important to know how does it do it, because if we're able to peel back those layers and we say, oh, okay, here it's identifying pixels that are in this one pattern, then we can say, oh, is that something that humans didn't know, and we can now have that knowledge and use that same emergent pixel pattern in other cancers or in maybe skin textures that aren't as successfully read in this AI? What I'm trying to say is we need to know how AI knows what it knows, or rather, if we do that, it'll help us to better design our AIs. Wouldn't you say that's a good goal, right?
Yeah, interpretability it's called, and if you look at where it is now, there's a really close boundary in terms of people can understand, like, when I've dug into this, like the first two layers, but you always hit this point where I call it like the magic zone, and then our explainability just goes to zero. It's interesting. And so the more we know, the more we know.
Yeah. It's a little scary in one sense that there's knowledge that exists that we don't grasp yet still that knowledge is key to improving our own understanding and even like an overall theory of knowledge. Okay, so in this outline, I want to real quick shift to going over your first video. You have some fabulous diagrams here where you have some diagrams of what's happening in basic brains. Then we have examples. Some of my favorite examples from your first video is there's things like bacteria that can only sense smell and can only either go in a random direction or a fixed direction. We talk about Venus flytraps, as well as, I didn't get the name of the leaf. There's a leaf that curls up, but it can learn to not curl up. Can we pull up the diagram? Allegra, by the way, my producer today is Allegra. She's in the back room. She's pulling up all the images. How are you doing, Allegra? Yeah. Allegra, you're awesome. Can you pull up the diagram, the sense action diagram? I think it's the second image in the folder. Okay. Well, there's not that one. That's a cool one though. That's a cool one. Keep it up though. Okay. That's a Chegg one.
My portfolio.
Yeah, we have a whole portfolio of them, which is fine. These are some great. That is that one of the AIs that are learning about itself, I believe. Sorry, not learning about it. Sorry, it's drawing a picture of itself.
Oh, there it is.
There it is. Okay, simple diagram. Very simple diagram. There's a blue circle with goals. Then it has an action and a sense. Brit, would you mind explaining the simplicity of this diagram?
Sure. So in the middle there, I know we might have audio, is just a circle representing, just call it an entity, which has some goal. And so the goal, again, just to be clear, could be survival. It could be something else.
Yeah.
It could be a sub-goal of that. And it can sense things, perceptions, arrow going in, and it can act sometimes by changing its body in some way. And so what I'm done here is actually looped the line, so it goes, the action loops around and becomes part of its sense. And that's a simple but important idea.
Okay.
I'm actually looking at it now. It's so simple. I lose sight of why I drew it.
It's all good. All right, Alexa, thank you so much. You can go back to the main cameras now. All right, awesome. So what I love the simplicity, because the question in your videos is, what is the simplest brain out there? And we were talking, and I forget if we were talking on Twitter or X, whatever it is, but we were talking about how when sense folds in on itself into action, and if something is able to like smell something and then choose an action from that, that is essentially the most basic type of a brain. It's something that responds to the environment. One example I've heard brought up is thermostat. You could look at a thermostat as a brain, or a coil, and in response to hot or cold, it expands or contracts. So that's one example. But I like your examples better. You had we said earlier, the first one was imagine a bacterium, a single-celled organism that only senses smell. And this baffles me because at a philosophical level, what does it mean to smell something? It's a very hard sensation. But is it from an evolutionary standpoint, is that the first sense that ever evolved, to your knowledge?
Yes. This it specifically smell. I just want to say that all senses are the same, and so they're just energy levels that hit this sensory neuron.
Yeah.
And I want to say senses, but I'm not 100% sure it felt right.
Cool. Yeah, no, I think that's great. Sense. Like you pick up information about your environment and you make a choice on it. And in a bacterium that's one cell, it can just smell, and then it can either go randomly or in one direction, and from that it can find a food source.
Yeah, and so the only other one, what's cool about sense is it's kind of like predicting something that's about to happen, which is quite advanced.
Yeah.
And so this other more primitive sense of just physical contact, which I'm aware of, now that I think of it, likely that came first, right? Mm-hmm. And we have examples of, you touch coral, you touch a fly trap. It knows what it knows when it hits it. Smell is, you're sensing something before it happens, which is neat.
Yeah. Big question that we have that we're going to explore further in this podcast is, how do our senses work? A long-term project is if you were to make an AI that had many neural nets that integrated a bunch of different senses, how could we approximate, mammal behavior in some sense, to some degree? That's why I ask this question now. Now, real quick, I want to mention something very important here. This here, without any more complexity, this very, very simple brain, this one diagram, one loop, it's a fixed action. You use the word fixed action in your video. That means it can't change. Something like, and I think the example used is a Venus flytrap or any kind of a trap. If you stimulate the sense on a Venus flytrap, it closes. And that's just about it. That it'll always close, and it's always the exact same thing. There's a slight evolution here when, and I think the example you gave is, let's say you've got a mutation and you have some more connections pop up inside that brain, and you've got some more wiring. And there's a diagram as well. And Allegra, if you could pull up the second diagram, or I'm sorry, I think it's labeled the third diagram. It looks just like this last one, but it's got more red lines. Look at this one. Looking at this diagram, I'm thinking about a very, very early neural network. You may have a different diagram in your videos, but I was thinking of those red lines on the inside. Basically, like if you have a neural network, there's a bunch of possible pathways, and not every sense will have the same result, and it can change over time. Thank you so much, Allegra. I appreciate that. And do you remember the example that you used of there's a plant where if you touch it, it rolls up, but eventually, if you're not a threat, it'll learn to not roll up with certain sensations. Do you remember the plant, what it was?
Yeah. And so it's good to repeat that, like, what's machine learning really doing? It's how to act. How to act is given an input, what's the output? I just like to repeat that because things can get confusing really quick to anyone new to this, how to act in, out. And so I was looking for examples where the connection between input and output can change in life, which is a huge advantage. And the way it first changes is not through new connections growing or anything. It's actually just turning down a connection, inhibiting a connection gradually. And this is what's so cool, where habituation comes from. It's just not doing something as much. That's kind of like this baby step in life learning. And this is a leaf that, after a while realizes that getting hit by water is not a bad thing.
Yeah, it's funny. It's all in how you explain it, right? I've had a whole lot of philosophical conversations with people about are plants conscious? Whether you talk to somebody who's no offense to hippies or anything, but like are plants conscious? And I would think in my background, no, a plant is not conscious. There's no brain. Yet, if we just break down the single task of learning through this slightly more complex internal wiring, it doesn't curl up as much when it doesn't die, or it's not threatened. And it's not that it understands what you are specifically, it just is able to build an understanding by virtue of still existing and being healthy. The sensation to curl up weakens over time. That's all it is. Yet we can still say, or if you choose to word it this way, it gets used to you touching it, or it gets used to raindrops, and it no longer curls up. So it's fascinating. It's really fascinating. So
cool.
wow. In the next section, I talk more about conditional learning, but I think we touched on that pretty well actually, where we talk about like dogs and bells ringing and salivating. You do talk in the video about what makes
again. Sorry, just pause. Sorry, just to interject there, because this is an example where I used to get really confused with like. Okay, you got the one Pavlov's experiment everyone knows about, but there's so many experiments, and you can think that you need to know them all. And if you're thinking from the top down, the human brain's so complicated, you get lost very quickly. And so I'm glad you moved on, because really what you have to know is, can a connection change in life? I don't care about the context. We'll get all confused thinking about context. It's, can a connection change?
Yeah, and that's basically it. And then other examples in this video, like you move on to abstract thought in human brains and all that, and it all comes down to these basics, and just through mutations in hardware, we get human brains as we know them today. All right, so what I'd actually like to do is move on to your video series on machine learning. Now this is one where in this outline I didn't have a whole lot of videos. There was so many videos to choose from. I didn't get a sampling here, and part of me wishes that I did, but I'd like to talk a little bit about the early research into machine learning and some of the clumsy early models of a neural network, ones where you had to like manually change each dial. I was hoping that you could give us just a quick little preview of early research and the clumsy early models.
Sure. I'm glad you brought up a dial. So the original dream was, let's make a mesh of wires with just neurons and wires connected. And a neuron is like in electrical terms, it's a transistor. If it gets enough energy, it turns on. So you need something to be your neuron, and that thing basically you can use a transistor. And the only other thing you need is connections. But we need to be able to change connections. And so this is why I used, and I made this up. I don't think they didn't use this, but I used a dimmer switch to hint at this idea of a dimmer switch is a variable resistor, which allows you to change the strength of that connection electrically. That's all you need. Then you have to give it, again, machine learning, all of learning, input, output, how to act. And so the first experiment was so great. Rosenblatt's was just, like, he used like 50 neurons all connected together, thousands of wires, but he would either draw on like a light, bright style screen, very low resolution, a circle or a square, and then have the machine learn circle versus square. And how do you learn? Well, you got to give it some experience. So he'd draw a circle, put it on an initially random mesh of connections. And that I need to amplify super clear, because there's not much to machine learning if you got the core right. Random mesh of wires, well, it doesn't work at all at first. What's not work mean? Well, the output is forced to be one of two things, and we can call it circle or square. And in this case, that's what he wanted to do. And so when you put but it does nothing at first. So you put a circle in this machine, and what happens with the two light bulbs at the end? The machine doesn't know anything. They're both kind of lit up just kind of randomly. And so it has to learn. What's learning? Well, in this case, the human kind of cheats a bit, where we show it a square, it does some random thing that doesn't work, then one by one, we go through and wiggle each dimmer switch. And sometimes going one way will help, meaning, I, a human, am going to let's call the top light bulb a square and the bottom light bulb a circle. Anytime I put a square in and I do a wiggle, when the right light bulb gets brighter, I'm going to keep that wiggle. If it doesn't help, I'm going to go the other way. And you literally just do that through all the neurons. Keep doing that, and you hit a point where you put circles and squares in this network, and it doesn't need you to do any more wiggling. That's the time that it has generalized, which means it'll work on what it was trained on, But most importantly, it will work on new circles and squares you draw, different people with different handwriting, different pixels, basically.
This was the very first half of my interview with Brit Cruise. This first half, we focused on what is intelligence and what are examples of intelligence in the natural world, different kinds of brains and that sort of thing. The next half of the interview, which will be airing next week at the same time and place, is all about machine learning specifically and what are the architectures in artificial intelligence that allow it to be so successful. Things like attention networks and transformers and things like that. So next week is all about the artificial intelligence side. Stay tuned. We'll have a great interview next week.